So this is an actual page from a previous calculus exam. This is from the free response section. And it's the last 3 questions, which indicates it's a non-calc. This is from the non-calc portion. So these are the kinds of questions that are worth 9 points. First, I'm going to solve this, and then I'm going to show you how it's scored. And notice it's just 2 sections, A and B. And it wants us to first sketch the slope field, and then find the particular solution to the differential equation with the initial condition. So this part here is the initial value problem part. Okay, this was a different question here, so I'm going to cover this up with another sheet of paper. And you can feel free to do the same so you can have plenty of room to work out number 5. Okay, so first let's go ahead and make the slope field. And notice it just asks us to make the slope field at the 8 points indicated. So I only need to worry about 8 points. But because the derivative has both x and y in there, I need to do a different input for each point. So I'm going to have an x column, a y column, and a dy dx column. So the first xy that I'm going to use is going to be 1, 0. Then I'll go ahead and do 1, 1, and 1, negative 1. Then I'll go ahead and do 2, 0. And then I'll come over here and do negative 1, 0, and negative 1, 1, and let's do another chart over here to continue. And negative 1, negative 1 for this one here. And then last but not least, negative 2, 0. And let me just double check and make sure that's 8, because you always want to follow instructions and make sure you're doing exactly what's asked of you. So this is 1, 2, 3, 4, 5, 6, 7, 8. So I feel good that I'm doing what I'm being told to do. Okay, so now I'm going to plug these in here. So for this first one, I get 1 plus 0 divided by 1 is just 1. And then for 1, 1, I have 1 plus 1 over 1 is 2. And then for 1, negative 1, I get 1 minus 1 over 1 is 0. For 2, 0, I get 1 plus 0 over 2 is a half. For negative 1, 0, I get 1 plus 0 over negative 1 is negative 1. For negative 1, 1, I get 1 plus 1 over negative 1 is negative 2. For negative 1, negative 1, I get 1 minus 1 over negative 1 is 0. And for negative 2, 0, I get 1 plus 0 over negative 2 is negative 1/2. Okay, so at the point 1, 0, I'm going to sketch a slope of 1, which is somewhat steep and positive. At the point 1, 1, I'm going to sketch the slope of 2, which is slightly steeper, still positive. At the point 1, negative 1, I'm going to have a horizontal tangent line. At the point 2, 0, I'm going to have a less steep slope than here, because 1/2 is less than 1, but it's still positive, just less steep. Okay, at the point negative 1, 0, right here, I have the slope of negative 1, which should mirror this one, but just be going the other way, because it's the same number, but just negative. At negative 1, 1, I have the slope of negative 2. At the point negative 1, negative 1, I have another horizontal slope. And at the point negative 2, 0, I have a negative slope that's less steep than 1. And we're done with part A, because it just wanted us to sketch a slope field. So there's our field of all the slopes. Okay, now for part B, it wants us to find the particular solution, not just any solution. This is all the solutions here. The particular solution with this initial condition. So here's where you want to follow the 5 steps. Okay, so step 1 is separate the variables. Y's go with dy, x's go with dx. So I'm going to have to divide the 1 plus y to the other side and multiply the dx to the other side. So I'm going to end up with dy divided by 1 plus y equals dx over x. And that looks a little funny, so maybe we'll rewrite that as 1 over 1 plus y dy equals 1 over x dx. Okay, then step 2, we're going to go ahead and integrate both sides. Now, this side here, you all can do with the information you've been given so far. This side is ln of absolute value of x plus a constant. This side here, we're going to learn how to do that in the next section. So for right now, just like don't worry about how to do this, because you're going to learn how to do this in the next section. And basically, it would end up being ln of 1 plus y. Okay, so for right now, just sort of go with that. And the next section, we'll see why this turns into that. The main idea for right now is to understand that we're taking the antiderivative of both sides. And this c right here is a combined constant. Okay, then I want to plug in my initial condition. Oh, wait, no, sorry. I need to get rid of the ln's. That's right. I need to get rid of the ln's because I want to solve for y eventually. So I'm going to raise both sides. I'm going to do e raised to both sides. This is kind of a unique situation because I need to get rid of the ln's. That's right. So those cancel out, and I have absolute value of 1 plus y. And then here I'm going to use the rule of exponents that says when you're adding the powers, really what you're doing is multiplying bases. So this turns into e to the ln absolute value of x times e to the c. Okay, now the next thing we want to do is get the 1 plus y out of the absolute value. And the way that we solve absolute value equations in algebra is we just set 1 plus y equal to the positive and negative of this number. So one thing we can kind of get fancy with right here is we can say, all right, let k, a new constant, introduce a new constant, be the plus or minus version of e to the c. Because this right here is just a number. Because remember, c is just a number, and e raised to a number would just be yet another number. We could call that k, where k could be either plus or minus. And that allows me to get rid of the absolute value because this would be my plus or minus. So I'm going to just get rid of the absolute value, and now we're going to put k in place of e to the c, all the while recognizing k could be either positive or negative, e to the ln x. Okay, so we're almost done. We're going to go ahead and substitute in the initial value. And the initial value that was given earlier was negative 1, 1. So just keep in mind, when you see an initial value given to you this way, this is the x, this is the y, so it's negative 1, 1. So I'm going to plug in negative 1 for the x. Oh, this cancels out, doesn't it? Sorry, so this is 1 plus y equals k absolute value x. Okay, so I'm going to plug in negative 1 for the x and then also 1 for the y. So I get 1 plus 1 equals k times negative 1 inside the absolute value. So I get 2 is equal to k, so k is 2. So then my step 4 is to solve for y. So I have 1 plus y equals 2 absolute value x. Go ahead and minus the 1. And there's my solution for y. Okay, but notice earlier in the problem, it did specify to state its domain. So we need to always read the directions. We need to state its domain, and we want to be careful here. So notice how this derivative is defined. This derivative is defined where x is not 0. And in order for the derivative to be defined, the function must have been smooth and continuous. And what do we know about absolute values? Well, they're smooth and continuous on either one side or the other, but like this graph right here would have a sharp corner in it. In fact, the way you graph this is you'd go down to negative 1, and then from there you'd go up 2 and over 1 on both sides. creating the sharp corner. So we want to give this function a domain that would not include that corner. I don't want to include that corner. And I want this to be smooth and continuous on the whole interval. So I'm going to pick either the right side or the left side. So let's notice the initial value I was given was actually this point right here. I was given the point -1, 1, which is on the left side. So for this sort of interesting example or sort of unique example, the domain for this, we would just use the left side of the absolute value where x is less than 0. So we would just use this side. Okay, so now let's compare this work that I did here with the actual solution for this graph. This is the released solution to this AP test question. So here's their slope field. Here's our slope field. So their slope field, our slope field, I'd say we nailed it. We nailed it. So that gets you 2 points. So right away you've got 2 out of 9 points for the slope field. So these questions are great because you have all kinds of possibilities for partial credit. This second part that we did is worth a total of 7 points with all kinds of partial credit, but pay attention to this. You get 0 out of 6 points if you don't separate the variables. That is huge. Because look at all of these possibilities, all this partial credit you can get as long as you begin by separating the variables. If you don't begin with that, you don't get any of these points. So we want to begin by separating the variables, which we did. And then you take the antiderivatives, and they called their combined constant k and then switched it to c. Doesn't really matter which way you do that. You just want to call it a letter. They took e of both sides, changed this e to the k into a c, got rid of the absolute value, solve for c. We did all that. You get 2 points for finding each antiderivative, 1 for this, 1 for that. 1 point for simply writing the constant of integration. But notice this, if you don't have the constant of integration, the most you could get is 3 points, because from here on out, they wouldn't give you any partial credit. So this step here and this step here are crucial if you want to get partial credit. You got to separate your variables, and you got to write your constant of integration. Okay, then you get another point for simply plugging in the initial condition. And then you get another point for solving for y. And then you get the last point for stating the domain, x less than 0. Now notice if you weren't able to see that, like if you said all real numbers because we're used to saying that that's the domain for absolute value, you would only have lost 1 point. So that's really not a huge deal. All these other steps are way more important. And then also just kind of point out what this means right here. All this is saying here is, because if you recall back when you first learned about absolute value, it's actually defined to be x if x is positive and negative x if x is negative. That's how absolute value is defined. So like 2 absolute value x minus 1 is defined to be 2x minus 1 if x is positive, and then 2 times negative x minus 1 if x is negative. And then if you simplify that out, you end up with this, negative 2x minus 1. So they were just basically taking the left side of the graph. And also, if you look at the graph, which I'll just go ahead and sketch right here, because you see our graph fits our slope field. If you look at the graph, and if you ignored this side of it, and you were only looking at x greater than 0, this is the graph of 2x minus 1, because it's positive slope of 2 and a y-intercept of -1. And if you ignored this side and only looked at the left, that is the graph of negative 2x minus 1, because it's a slope of -2 with a y-intercept at -1. So it's good to see how all of these things connect. Okay, so that's it for this portion of the notes. And actually what you guys will be doing in class is working on other similar style AP test questions. So this is sort of your first experience with the free response AP test questions, so you can kind of get a sense of what they're like. Okay, so I'll see you in class.